Okay, you guys can still hear me, right?
Mm.
Okay.
Yeah.
Okay. So today we are going to look at a little bit of a different topic, which is basically the basics of containerization and how why containerization is required and why it is needed, and then we can go from there. Basically, this lays a foundation of the discussion on around a famous concept or a famous name that you have heard. That is called Docker. So we will go there. What is Docker? Why not? But this is a couple of steps that we need to do before that, and then we can go there. Okay. So before we talk about containerization, let me ask: do you guys remember from your engineering computer science class the basic uh, architecture of an operating system?
Uh, yeah, I mean, you mean to say those CPU, memory,
Correct.
disk,
Correct. Correct.
cache? Yeah,
So
yeah.
we'll very high level we will start and we'll see. So what we are discussing today is discussing containerization. Okay. So so I think let's just draw a picture. Okay. So here, if you remember, there was this is general structure of our operating system. Okay.
Mm.
Here in this layer we had what? This was the hardware layer, right? In here, we used to have CPU, we used to have memory, and then we used to have storage, uh, right? Then we used to have like network interface cards. We used to have graphics interface cards, and some other peripherals like keyboard, mouse, etc., webcam, whatnot. Everything is there, right? So on top of it, there used to be a space till here. We can name this as what? Kernel. What is kernel? Do you remember? So kernel
Mm.
is basically the code of the operating system that has
Code.
complete control on everything on the operating system. So
Mm.
kernel actually is nothing but it is responsible for basically it's the brain, you can say, of the operating system, right? So it is responsible for process management, it is responsible for memory management, device driver management, system call, file system management, IO, etc. I mean anything that you can specifically think of, right? So then basically in kernel, uh, I can tell you that basically there is a uh, there is here is memory management section. Then here is a process management section, right? Then you have IO management, correct? Then
Mhm.
you have file system. uh, Then you have network stacks, security, etc., etc. So this is basically the brain, right? So within the kernel space, there is also a major thing that helps interaction with this. It is called device drivers, right? These device drivers are responsible for interacting between the hardware layer and the kernel layer. So, drivers are basically the program that exposes the hardware and that basically interfaces and gives you the uh, ability to interact through a software to the hardware, right? I think these are all refreshers, right? Then on
Mhm.
top of it, you have user space management, right? So here you can say this is basically a user space where in between this you have uh, here you can have libraries, you can have services, this, and then you have other utilities, right?
So basically, in the file structure, this is the place where all the libraries and the utility files
Yeah.
reside, right?
Yes, yes.
Okay,
So
okay,
I'm
yeah.
just so if you
Mm-hmm.
see, I'm just building up from ground up,
Yep,
correct?
yep.
This is the hardware. Then you have the device. Then you have the kernel. Then you are basically having the
The particular apps,
apps,
probably.
right? So apps is
I mean, on top of it, probably.
here you have uh, sorry, here you have basically this is actually the system architecture. It is not OS. I should not say this is OS. So this is basically a system architecture. So here you have OS, right? And then on
Mm.
top of it, here you have the app,
System architecture, correct.
right?
Uh,
Okay, this is what we
forgot
know.
uh, I forgot the library services. Which part it is?
Yes, basically, if you are interacting with any system library, like say anything that you do, right? That the OS is handling the say file copy and then the file write, copy and part. So there is somewhere you have the operating system that is natively talking about any particular exposed libraries, right? So, for example, in Linux or Unix, you have a separate folder which does that. But generally, say a good example would be uh, something like you have mm, might be your a hard disk cleanup software, right? So once you are booting up your OS in previous days in Windows, if you remember, if you press on F8, it goes to the system panel, right? Then you enter the
Mm.
DOS mode, right? And in DOS mode, you can actually do some OS operations, and you can, create partitions on them, and you can, create multiple operating system, and you can install, like, right? So that kind of program is written somewhere, correct?
Mhm.
That is exactly the layer. So this is the user space where basically you have you have any kind of services, whether you have any native services, anything that you have a network service, you have your gaming console that is actually interacting with the OS, and it is also giving output to your speakers, etc. These are the things that actually require some gaming softwares, right? It would be at this layer, right? It is a little bit up than the device driver, but it is actually at the level of which is below the OS, correct? So if you remember, when we used to, I forgot that name of the game, when we used to play, I think it was Carbon, right? The Need for Speed Carbon, NFS Carbon. So if you used to
Mhm.
play Need for Speed Carbon, there used to be a separate graphics card setting. On top of it, you have to install certain services, right? Otherwise, it will not interact with your IO in the right manner. correct?
The virtual sync and other things, if
Yeah,
I'm not
virtual thing,
forgotten. Right. Yep.
virtual NIC cards, all those.
Mm-hmm. Yep.
So that's basically it's a top layer abstraction of it, right? Uh, any other question, Parthu?
Actually, this library and services, it should be under OS, right? I mean, within OS.
Uh, within OS, let me think. Mm, you can say so. So basically, it's the user space that refers to the memory area where the application software and some drivers execute, right? So you okay, let me give you let me ask you one question. Did you heard about any background process called daemon?
Oh,
Where does
okay.
daemon run in this
Okay,
diagram?
no, yeah, the daemon is, if it is a
Okay, tell me
daemon,
one
yeah.
thing. Tell me
Hmm.
another thing. Where
Hmm.
does a graphical user interface or a command line tool run?
Command line tool. Command line tool is,
Where
it's
does a service manager run? Tell me this.
service manager.
Hmm.
Service manager.
So if
Is
you think that if you think
not
that
part of
it is it
this.
is
Hmm.
directly OS, it is not, right?
Oh.
There is a layer between the devices and there is and that is exactly we will see that what exactly is the thing. So when the system call happens, basically from a user space library, okay, let me tell you.
Is it nothing but the DOS thing? DOS?
No, 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 no. So okay, let me tell you this. I think okay, it will take a little bit more time, but let it is very important for us to clear. When there is a boundary between a user space and a kernel space, right? So
Mm-hmm.
when there is a user application, so say suppose we have user space libraries, say like you have glibc, libc, etc., right? These are generating function calls, right? These function calls are translated to system calls and then it goes to the system call interface. So basically, there are two different boxes here. If you see, here you have the user uh, say space library, user space, and here you have the kernel,
Mm.
right? So when there is a system call that initiates from here, right? This is generally say library function call, which is, for example, you might have heard about something called glibc, or you have heard about something called threads,
Mm-hmm. Trades, I know.
right? So
Mm.
these things, if you call here, these are what? These are typically function calls, right? But
Okay.
when it goes to this layer, so when it goes to this layer, this is interpreted before entering here, it becomes a system call, right? And that's where there is an interface here. Do you know what is interface?
The the
Interface,
CLI?
no. Interface is a system that exposes the um, underlying hardware or the capacities of any other system in a more user friendly way. So the processes that are driving the kernel, you will not know that processes. This is written perhaps in Windows in C++ or in Linux. It is
Mm.
written in Unix. You wouldn't know that name of the process, correct? But if you have to call a particular process, how will you call it? Somebody has to translate that function call to the system call, correct? That is
Mm.
exactly what the interface system call interface does, right? Where does the system call interface sits? It sits in between your kernel and OS.
System call sits between kernel and OS. Okay.
Otherwise, you will not be able to kind of, you know, distinguish between these things, right? It sits between exactly between that. So it gets translated, and then it will get a response, and it will get back to the user space. Correct?
Kernel is nothing but the brain of the computer, is it?
Yes, kernel is nothing but you can just say that it is the brain of the computer.
So
But
in the left picture, where kernel fits.
so okay, so let me draw a different diagram in that case, right? So this is basically it's called a ring diagram. So I will try to mm,
Okay, okay, ring diagram, the
yeah,
circle one, the
circle one, circle
update and
two.
all.
Yes,
Yeah,
yes,
yeah.
yes,
Now I can.
yes.
Yes.
So basically here, let me. I'm sorry, but this is again not my area of expertise, but I'm just trying to remember. Let me see if I can. So I think the first ring, the ring 0, was this, right? This is cardinal.
Mhm.
And then in about the ring diagram, there were drivers.
Hmm.
Then outside the drivers, this is OS services, right? And outside this sits your application.
Applications.
So your privilege is application has the lowest privilege and kernel has the
Hmm.
highest privilege, which
Hmm.
means kernel has the full hardware access, and it talks to it's basically it is the one that is actually helping to do the process management, memory management, device driver management, whatever, right? And it sits exactly where? It sits exactly on top of your hardware, beneath your OS, right? So this is the person who is trying to help you in order to translate the command that you are giving to operating system to the hardwares, and it is taking the response and again converting it back, right?
The
So
kernel.
yes.
Mm. Mm.
So if you
Clears my doubt actually. Yeah, thank you.
sorry.
This diagram clears my doubt actually.
Okay. So if you are yeah. So I think this is let me name this. This is 0, this one 1, 2, 3. Correct? So this is type 1. Okay. This is okay. Okay. So this is the up till this was general knowledge of I guess
System diagram.
operating
Mm.
system or
Mm.
general architecture.
Mm.
Any confusion?
No, 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 now it's perfectly okay. Thank you.
Okay. So let's talk about a concept called virtualization. What is virtualization? So virtualization is nothing but a technology that creates versions of virtual computing resource. So it is nothing but it's a technology which creates uh, virtual virtual versions of any computing resource. Why did it sound so quirky? Now, the thing is that if you go back to that diagram, let's make that diagram once again, right? Where what is virtualization? This is very important to understand, right?
Mm.
So, and I'll draw the diagram in a different way.
Virtualization.
Here you have hardware. It is clear, right? I'm
Mhm.
Mm.
I'm jumping all the others and say here you have the operating system, right? You in between, we know there is kernel, there is all these other things that we just discussed, system calls and everything happens, right?
Mm-hmm.
Mm. Mm. VMware. Okay.
One second, let me complete this and then I'll get back. Okay.
Mhm.
Okay. So, so we are clear up till this, right? There is
Mm.
hardware, there is OS, right? Now there is something called hypervisor. So hypervisor is nothing but that it's a software, right? Have very clear understanding that hypervisor is nothing but it is a software that connects your physical hardware and separates the resources so that they can be operated in an isolated manner, right? So hypervisor is what? Hypervisor is a software that sits on top of the host OS.
Oh, this is guest OS, this is host OS. Okay.
So
Mm.
now when the hypervisor is installed, it basically separates and gives you the resources of of the hardware. Basically, it will create some uh, segregation like this, and it will allocate this to a VM1. It will allocate this to VM2. Similarly, it is going to allocate this to VM3, right? So the hardware sections are virtually, it is being allocated in, it is not happening physically, it is happening virtually. It connects to the physical hardware and separate it so that each of them can operate as a single unit. Now with this you can understand that you would be getting what? You would be basically getting, you would be basically
Uh,
getting a
three machines.
virtual memory. You'll be getting
Uh,
a virtual NIC card. You'll be getting a virtual I mean all hardware that is required, right? On top of it, then you can install any operating system you like. So you have a Windows operating system. Now if it is virtualized, you want to install Ubuntu on top of it, you can install Ubuntu. That becomes your guest OS.
oh, okay. Mm.
Tomorrow you want to install a Mac, that becomes another guest OS on top of the same on top of the same hypervisor, on top, sorry, through the same hypervisor on top of the same host OS, but that's a separate uh, virtual machine. So this is VM1, this is VM2, This is VM3. Okay.
So this guest machine will take the hardware from host machine only, but
Yes.
all are virtually, not physically.
Not physically. Correct.
So hypervisor is a software that connects
That
my
connects the physical
physical
hardware,
hardware.
that connects the
Ah,
physical hardware and
mm,
separate the machine resource in such a way that they can operate in an isolated manner.
okay.
And it can distribute it on different virtual machine.
Okay.
Okay.
Understood.
Okay.
Um, I have a question actually.
Hmm.
So, virtualization. So this hypervisor is basically just a software ultimately, right?
Yes.
That basically enables the virtualization process. But before jumping into virtualization, can you probably help us understand the difference between? I mean, I kind of get confused between sometimes between the containerization and virtualization, like how they're actually different.
I haven't talked about containerization yet.
Oh,
Everything
oh,
talked
oh,
about
okay,
is virtualization. Let's not get into containerization. Let's first clarify.
okay.
I started with general operating system.
Mm-hmm.
I know that I am talking about containerization, but before talking about containerization, you need to have these are the primary knowledge. You should have a good understanding of system architecture. You should have
Mm-hmm.
another knowledge of what is virtualization, and then only we can talk about containerization. Before you understand these
Oh,
things,
okay,
you
okay,
cannot understand what is containerization.
okay,
Hmm.
okay. Makes sense.
No, it's very important topic which you are covering because this is a base. Without this one, like I mean, no one can understand the conversation.
Hmm. So
Thank you so much.
this is yeah, this is containerization is something different. I will come to that, but I just wanted to understand. So I'm not getting into details of any virtualization. And again, I'm not an expert of this, but we know what is the benefit of virtualization. We know we have all worked into virtual machines. We have connected in our workplaces. So basically, you have scalability. You can do cost savings. You can have efficiency. I mean, all things, all good things that come with it, right? So, what was the problem of virtualization that containers came into existence? So before that, what is containerization? We need to understand. Containerization, before talking about containerization, and let's not confuse between containerization and Docker, right? It is the same confusion that you have between photocopy and Xerox. Xerox is the name of the company, the technology name is photocopy,
Mm-hmm. Right.
right? So containerization is the name of the technology, Docker is the name of the company, right? Do
Yep.
not do not get confused with Docker. We have not talked anything about Docker yet. We have just talked about general operating system and virtualization. Any confusion till now?
Oh, perfect. Perfect.
Okay. So now let's dive into containerization. So before containerization, let me tell you one story. So this is a developer, right? And this guy is a tester. So a developer does development, this guy tests it, and this guy gets back with a bug. So this guy gives a code, and this guy comes with a bug. This is common. We know this, right? Correct?
Hmm.
Hmm.
Okay. Now, have you heard this thing? I mean, I'm not sure if you have heard this joke. It, it says it works on my machine.
Machine. Yep.
This is a classic joke of
Yes.
IT. It,
Yes.
any developer would go and just say to the tester that, it works on my machine, it does not work on your machine. So
Mhm.
whether it is a bug or not. So if the first thing that a developer does whenever the bug is raised, the developer will go and say that, you know, prove that this is a bug. This is not any other thing. This might be, a system behavior. That is the first thing that a developer does. I mean, I myself have done it thousands of times. So, but I mean, treating a bug like a feature. But anyways, but it is a classic joke that says that it works on my machine, and somebody over here says that it doesn't work on my machine. Right? So here the thing is that this problem is the classic problem of what?
Virtualization.
No. Why it is a problem? Why do you think, Partho, it is a problem of virtualization? This is a classic problem of what? This is a classic problem of environment synchronization.
Environment
Mm,
synchronization.
Whatever environment that the developer is developing, whatever OS the developer is using, whatever version of the software that the developer is using, it is not being used by the tester.
mm.
Then the same code that works on the developer machine, it does not work on the tester machine. Partho might be thinking that the developer is actually trying to tell lie. For one instance, think that the developer is not lying. The developer, I mean, is actually saying that it works on my machine, but the tester says that it does not work on his machine, right? So if the problem is there, it's a problem on what? It's a problem on environment synchronization, right? Do you agree?
Mhm.
Hmm. So this is a age-old problem. Now, in order to overcome this age-old problem, and I just wanted to lighten the mood a little bit, because we are discussing so heavy topics here. So, in order to discover a solution of this particular problem, there came the concept of containerization. Now, what is container? We will come to the containerization part, but basically, by definition, containerization is a software deployment method that packages applications into containers. Now we will say what is you can say what is container, what is everything.
Sorry,
So
repeat this line. It is a
it is a
deployment.
software deployment methodology, right? That packages applications into containers. Or in other words, you can say containerization is the packaging of software code with just the library, I mean the operating system library and dependencies required to run the code.
It's a packaging of software code.
Let me write it down. So container, T-I-N-E-R, containerization. It is what? This is a packaging of software code, packaging of software code with just the
Library and dependency.
OS libraries and dependencies required to run the code, required to execute the code. You can also go on saying it creates a, sorry, this request to run the code, right? Now this creates a lightweight executable which is called container. So since you are interested in definition, This is what I should say. Now, the property of a container is that it can run consistently in, sorry, on any infrastructure. So what did we say? So we'll break it down. So containerization is nothing but a packaging. It's a software deployment methodology. We are okay with that, right? We are saying that it is a packaging of, and you will get this definition from internet because I just looked it up from internet and I just wrote it down. So it is not very something that I'm just telling it from my brain. It is not like that. The definition is all there, Partho, in the internet. So
Mm.
the packaging of software code with just the OS library and dependencies required to execute the code, right? So we will come to this line a little bit later. Let's understand from our age-old diagram, right? What was it? This one, we had hardware here, correct?
Mm.
Now, on top of it, just 1 second, we had, what did we have? Host operating system,
Host OS, yeah.
correct?
Mhm.
Now, here we had hypervisor, if you remember,
Mm.
right?
Mm. Mm.
In place of hypervisor, here we have something called,
Container.
no, container engine.
Oh, container engine.
And in place of this, we have, these are binary or libraries. These are app. Okay. What is the main difference between this diagram and this diagram?
We have hypervisor on that one, which was basically managing the software. And here we have a container engine, which is basically actually giving you providing the infrastructure instead of basically running as a software. It's providing the infrastructure entirely for the container.
Okay, look again. That is very obvious. Look again. Did you
The
look at this
guest
diagram?
OS, yeah,
Very
the
good. Yes, that is the main difference. Here, there is only one OS. Here, there is no concept of guest OS, right? Now see how the concept has changed. I am not, in this case, I was virtualizing the hardware through the OS by the help of hypervisor, which is virtualization. In this case, I am virtualizing the operating system
Virtual operating system.
because if I virtualize the operating system, I am just creating a space, a dedicated space within the operating system and dedicated library where the dedicated library and binaries can exist. And within that dedicated space is called namespace. I am declaring namespace within the operating system and I am treating that particular dedicated unit as a segregated, isolated, operated unit. That is the difference of a container.
Sorry, what? Oh, So how is the difference? The virtualization does what again? Sorry.
Virtualization, here you had a guest OS.
Right.
And within the guest OS, what were you doing? You were getting a virtual uh, uh, memory. You were getting a virtual NIC card. You are getting
Right, right.
anything virtual, right?
Hmm, hmm,
Then basically your virtualization is a concept that basically created a computer within a computer,
Computer within a
right?
computer. Yes,
Now
So
true.
that
it's basically
computer,
virtualizing the.
wait. That
Sorry.
computer within a computer, the child
Mhm.
computer starts with all the hardware detail. The
Hmm.
child computer has all the hardware things also. The only thing is it is virtualized. It is not real. Correct?
Just like the mini computer.
Oh, okay. Right,
Correct?
right, right.
Just a
So
mini
it's base.
computer. It has a virtual,
Mhm,
it has a virtual memory, it has a virtual graphic
mhm,
card, it has a virtual NIC card, anything. Right?
Everything is
And
in a.
mhm,
and you have to install another operating system within that computer of over the computer. So within
mhm,
the
mhm,
child computer, within the parent computer, within the virtual,
mhm,
you have to operate another operating system. You have to install that operating system. Then on top of it, you can install your application and whatever. So computer within a computer is the concept. Correct?
Hmm.
mhm,
This is
mhm,
virtualization. Now come to
Hmm.
containerization. What we are saying in containerization is that we are not creating computer of computer, but
mhm,
what do
mhm,
I need in order to execute the program? I just need a small portion of my operating system's libraries, nothing else. I just need a small portion of the memory. I just need a small portion of the operating system library. I just segregate that, duplicate or create duplicate copies of that, and name everything as separate namespace. And within this namespace, I create a separate entity which is going to be an isolated unit called container, not virtual machine. It is called container because it does not have any virtual hardware. It does not have any virtual operating system, but it has a bare minimum component that can help run your program. If you say Python print Partho or print Obhinandan, the only thing that it needs is a virtual portion of the operating system, because remember, till this portion everything that was there has already been taken care of by your downstream process. Now when you are sitting at the operating system level, everything that you have, it is if you remember the initial diagram, right? It is already at this OS level, correct? On top of OS, we what we generally do is that we install the applications, correct?
mhm,
In,
mhm,
now what we are saying, we will install the application, but instead of just nakedly installing the application, I am going
mhm.
to declare a namespace, and I am going to only say that install this application within this namespace. That is, create a virtual separation within the OS memory, not at the level of your hardware. Create the virtualization at the OS level, not the way that hypervisor does. Hypervisor does the virtualization at the hardware level, right? But what containerization is doing, it is doing the virtualization at the OS level. Be very, very clear about this concept. Be
Doing
very, very clear.
virtualization in OS level, whereas
OS level. So
actual
it is
virtualization
segregating,
is.
it is
Hmm.
segregating the memory of the operating system. It is taking the bare minimum programs that is required to execute the Python library or Python programs, and it is going to create a thing like this. It is going to have, this is called a, say, namespace 1, and this is called a namespace 2, ns2, etc., etc. These are independent units. These are independent isolated units of processing. This independent isolated unit of processing is called a container. And that is exactly that this software does. Container engine breaks down the host OS, segregates the network, segregates the resources of the operating system to allow that virtual namespace to be created, wherein you can install any program that you like, you can install any dependencies, and you can just run your code.
So it's not at all dependent on host OS.
No, it is dependent on host OS, Partho. See, the host OS is the one which is getting virtualized, which is getting reserved. The namespace is residing where? At the host OS level.
Hmm.
Who is creating the namespace? Who is reserving the memory for that namespace? Container engine, right?
Hmm.
Container engine is reserving the memory or reserving the space to create that namespace. The only thing that the container engine does is that it takes the bare minimum
Resources.
resources needed from the operating system in order for you to
Create.
execute your program, because it can, you see, all the resources are available, right? Your kernel job is done, everything is done, and at the end of the day, your Python or your OS layer is coming into existence. Now the beauty of this part is that when you are coming to the OS layer, it just segregates that OS layer and it creates small chunk of exact same unit, but it is not
Mm.
going to virtualize everything. It does not need a hardware computation, it does not need a kernel, because everything is being taken care by the operating system. It does need the binaries that are getting converted and the libraries. It will take that, duplicate it, and create a namespace. Take that, duplicate it, and create a namespace. These
So
individual namespaces are called containers.
these individual namespace are called container. Okay. Individual namespace. Okay. Hmm. So based on the requirement, we'll create the different namespace.
based
Like
on based on requirement, you will create different namespace. But now come back to this definition, what we were saying. Now this container can run in any infrastructure, because it got the library, it got the binary. And if you install any kind of program, say JavaScript, or say you if you want to install a Node.js application, or if you want to install a database on a particular container, you are free to do so, but it is not going to interact your one container to another container. It is going to only operate within that particular namespace, utilizing the libraries and the binaries that are dedicated to that namespace. So what happens? What happens? What is the benefit? Benefit is that you solve this problem. It works on my machine. How? Now you can declare your environment, required version, and all everything in a file, and you can install it in any namespace. You just give that file to your tester and say, in order to run this program, you just have to create this environment. How do you create? You go and you basically install all these things into a namespace, and or basically that is what we say, that you have a Docker image, right?
Mm. Mm.
That is what we say, we have a Docker image. Now you take that Docker image, you create it on your own, and you basically run the program, it will run. It requires that might be the program requires a Postgres database, it requires Python, and it requires, say, some Python libraries, right? It will just install step 1, step 2, step 3. The way that it has installed in your machine, it will also install in his machine. The same version would be used, and it will execute your program.
I have just one question. I understood this part, but when I'm talking about when we are talking about the virtualization, so virtualization also had separate OS, separate thing, right?
Mhm.
So, but this problem that my it works on my machine. So this problem appears on virtualization.
No, this problem is not solved by virtualization
Is not solved by virtualization.
because you are not declaring as code that what is your dependency. You have you have to you in your virtualization, what your OS is different. You can use any OS. The
Hmm.
tester the tester uses a different OS than a developer. It can happen.
Hmm.
And then because it is computer within a computer, so basically the Python version can be 9 and Python version can be 11 on the same on the developer machine. It is 11 on the tester machine. It is 9. It can happen.
Okay, understood. So in coordination, you are saying like we can, after creating the Docker image, we can send it to some other machine or other person,
You
right?
No, it is not. You basically declare your dependencies in a file called requirement.txt.
Oh, you okay.
You
Mm-hmm.
basically say that in order for my program to run, you do not say that what version of operating system is needed. You do not care about any operating system. It is operating system agnostic because you are operating at a level of binary.
Because
You are
I am
operating at a level of libraries and binaries. Any operating system in the world which has Docker installed or which has a container engine installed, it will be able to run your program. All that you need is an environment to be placed, right? Environment means what? Environment means certain software to be installed. Software means what? Certain Python libraries needs to be installed, Python program needs to be installed, your database needs to be installed, and then your application has to run on top of it, right? So you declare everything as a part of your requirement.txt, and you put it in the time of your Docker building. Whenever your image is building, you just call that particular requirement.txt and you pass it as a parameter in the command when your image is coming up. Correct? So your
Mhm.
image would be built. The small chunk that will be built, it will be built by the same file that you have, the developer is using. The tester will also use the same file. The environment becomes equal. If the environment is equal, then the program is going to run.
Only thing is here we are declaring using requirement.txt and then
You are
virtualization.
Yes, you are declaring using requirement.txt, but it was not possible even in virtualization also. It is not possible. How would you declare? It's a computer within a computer. Can you have a computer declared with a specific thing? You can definitely have it as a part of the code, but look at it. You are basically creating a OS. On top of the OS, you are installing a programming language. You are installing a version of a database, and then you are trying to do it. But over here
Mm.
is what? You are basically reserving a chunk of your operating system, and you are saying that uh, within that chunk, I will just call it namespace. And within the namespace, what I get is an independent, isolated unit. I do not care what computer you are using. I do not care whether you are using Windows, whether you are using Linux, whether you are using MacBook. I don't know. All that I am saying is that I need certain fundamental, uh, you know, things in order to run my application. My application needs Postgres database. My application needs Python, and my application needs 5 other Python libraries. As long as that is declared and it can be installed in any operating system, your application is going to work.
So this, as you are mentioning, the namespace is basically taking a portion of OS. So this portion, I mean, some resources of OS. So that one is physically, not virtually.
This is a virtual reservation. That's what I told. It's a Partho, it's a virtualization of the host OS. It is not the virtualization of the hardware.
Oh, it's a virtualization of the
Reservation.
OS. Uh-huh.
That is
Okay.
where I said that it's a virtualization of the host OS.
Okay. Okay. Mhm. And what about the hardware part? It's using the host
It is the
hardware,
same hardware. It is the same hardware. We don't care, right? As
same
long as
hardware
the
as the host
Yeah,
OS.
as long as the OS you are able to reserve namespaces, you are good.
Mhm.
Mm.
So when we are supplying Docker image to one machine to another machine, if
Mhm.
the hardware is different, doesn't matter.
This does not matter. You are, first of all, you can, I mean, it is totally machine agnostic. If the hardware is different, if your system specification is different, it does not matter. As long as it is having a container engine, let's not call it Docker. Let's just say container engine. Correct?
Mm, mm,
Docker
mm.
Docker is just a name of the uh,
Company.
company. So let's
There are.
let's just say, yeah, let's just say container engine. As long as if you have the container engine which is able to do the containerization of your OS. Containerization of OS means what? Have very clear understanding. Creating isolated and independent unit of binary and libraries that can execute as a namespace. That's it, right? As long as it can do it, it will execute. It does not matter if you are running on Windows or if you are running on Mac or if you are running on Linux.
Mhm. Mhm. Clear. Thank you.
I think I'm going to stop the recording here. But any questions till now, then let me know. Okay, I'll stop the recording.